All right, statistics. We're going to be using our graphing calculators today to take care of this last section of lesson 4.2. If you did not bring your graphing calculator home with you, I sent you an email on Tuesday that gave you directions on how to download the calculator onto your computer. So Texas Instruments has given us a 6-month license for free so that you can use the graphing calculator online. Not online, basically, you have to download the app onto your computer. I don't know if that works on your Chromebook or not, but I know it does work on like your desktop computers. I downloaded the teacher version here at my house the other day and it's working really well. If you don't have access to your graphing calculator and you can't get the software downloaded, what you're going to have to do these probabilities in a faster way and then working them out by hand would be to use the tables in the back of your textbook, and I'll show you that method as well today. Okay, so let's go ahead and get started. I'm going to base the lesson on the fact that you can access your graphing calculator. So this part of the lesson is all about using technology. We're still going to set the problems up the same way, and then I'll tell you what keys to use on your calculator. Here we go. The results of a survey indicate that when grilling, 59% of households in the U.S. use a gas grill. If you randomly select 100 households, what is the probability that exactly 65 households use a gas grill? So our P is 0.59. You're going to have to know that for your graphing calculator. You have to know your N, which is 100. And you have to know your X value, which is 65. So we're finding the probability that 65 people out of 100 are going to use their gas grill. Now, the old way to do the problem would have been for you to set it up this way. 100 C 65 times 0.59 to the 65th times 0.41 to the 35th. So that would have been the way that you would have done the calculation the other day. What I'm going to show you today is how to put that into your graphing calculator. So to use your calculator, what I need you to do is turn it on and then open up just a regular calculate screen where you're going to just do calculations. And I don't know if these directions work for Scratchpad, so I would use the, let's see, what icon is that? When you're at home, it's that gray one at the bottom, the very first button with the times, plus, divide, and minus. So you're going to click that. Then I need you to push menu. And then we're going to choose probability, which is option 5. So it's menu, probability. And then I need you to hit distributions, which is 5. And then go all the way down to A, where you see binomial PDF. Click that one. And your screen should have 3 entry boxes. So the first entry box says N, so you're going to type in 100. The second entry box says P, so you're going to type in 0.59. And the third entry box says X value, and then optional. You're going to type in 65. All right, once you do that, you're going to hit OK, and then your answer should show up on your screen. And it should be right at 0.039 if you round it to 3 decimal places. Okay. Let me just try that again on mine. 100.59, and we're interested in if 65% or 65 out of 100 households use their grill. Yep. And I got the same answer you did. All right, now a binomial probability distribution is basically just listing a table with all probabilities. So This is that knee surgery problem that we had before. And so what the table is, it just shows you all values of X, so 0 to 3. So no knee surgeries are successful, all the way up to 3 surgeries are successful, and the probabilities for each. So again, each of these probabilities could have been found using this formula for each X value. That can be pretty time consuming and tedious. So what I'm going to have you do when you have to do a distribution, and to you that means a table, I'm going to have you use your graphing calculator to find all probabilities. Okay, so that's what we're going to do on the next slide. All right. In a survey, workers in the U.S. were asked to name their expected sources of retirement income. 7 workers participated in the survey, and they're randomly selected and asked whether they expect to rely on Social Security for retirement income. Now, I don't know if you can read this, but I'll enlarge it for you. It says about 1 in 4 will rely on Social Security, and that shows up right here as 25%. Okay, we're going to make a binomial distribution for this. So I'm going to move on down to the next slide. Our P is 0.25. We have 7 workers that we've surveyed. And our distribution is going to be a table. And there's a possibility that none of the workers surveyed say Social Security is going to be their source of retirement income. You might have one person that says yes, all the way up to 7. So what we're going to do now is go back to our graphing calculator and type in menu. And then again, it's 5, 5, A. Okay. I'm going to go ahead and do that on my home desktop again so I can kind of walk you through the steps. All right, in the first box, you're going to enter 7, followed by 0.25. Then I want you to leave the X value blank, because if you leave the X value blank, it's going to give you the entire distribution all at one time. You don't have to do the X value of 0 and then the X value of 1 and then 2 all the way up to 7. Just leave it blank, hit OK, and it's going to give you a set of values. And mine is going to start with 0.133484, comma, and I'm just going to write some of these down for you so you can see what we're going to do with them. I'm going to write the first 3 down for you. Okay, and then there's going to be 8 values. This is the probability for 0. This is the probability for 1. I wrote that wrong. This is the probability for 2, and so forth. So I'm going to just put that in my table. So the probability for 0 is 0.133484. These two happen to be the same. And there's our probability distribution. Now, I would tell you to round these to 3 places, and you should, except for this one, rounding it to 3 places just doesn't work very well for us. It would be rounded to 0. And I'm looking in your book right now, and they do round these all to 3 places. So if you wanted to do that, there's nothing wrong with that. Okay, so there's our probability distribution for this problem. This is one of our larger problems that we're going to go through here in just a minute. I'm going to get you started on it now, and then I'm going to stop my video and restart it. I can only save videos that are under 15 minutes long on YouTube. So I'm going to get you started, and then I'll stop it and come back to it in another video. All right, 59% of households in the U.S. subscribe to cable TV. So this is an old problem. You randomly select 6 households, so there's n equals 6. 59%, there's your P. And we're interested if they subscribe to cable TV. So we're going to make a probability distribution. We're going to graph it, so that will be a histogram. We're going to describe its shape. Is it skewed left, skewed right? Is it symmetric? We're going to find the mean, the variance, and the standard deviation. So those were those short formulas we used before. And we're going to interpret the results and talk about which values of x would be considered unusual. So we're going to tie in all kinds of ideas into this one problem. So it's coming up on the next video. Stay tuned.